In most homes, electricity is not experienced as infrastructure. It is experienced as outcome. Lights respond instantly. Appliances operate without delay. Heating and cooling systems adjust to preference. Devices remain charged. The process appears immediate and contained within the walls of the house. Yet residential electricity does not originate inside the home. It begins far away, at generation facilities that may rely on natural gas, coal, nuclear reactions, hydroelectric dams, wind turbines, or solar fields. From there, it travels across high-voltage transmission lines spanning long distances, through substations that regulate voltage, into local distribution networks, and finally through neighborhood transformers before reaching a residential meter. This layered system operates continuously. It must balance production and demand in real time. Electricity cannot be stockpiled easily at grid scale. It must be generated at the same moment it is consumed. The infrastructure enabling this process remains largely invisible to the end user. Power plants are geographically distant. Transmission corridors are rarely examined. Substations are fenced and closed to the public. What remains visible inside the home is only the final interface, a switch, a thermostat, an outlet. The reliability of this system has shaped modern domestic life. Refrigeration, lighting, communication, medical equipment, water heating, and climate control now assume uninterrupted availability. The infrastructure is not seen, but it is constant. When households think about electricity, the focus typically centers on consumption rather than structure. Monthly bills provide itemized usage totals. Smart meters display kilowatt-hour measurements. Energy-saving appliances advertise efficiency ratings. Homeowners may switch to LED bulbs, adjust thermostats, or install programmable timers. These actions address visible consumption inside the home. They do not change the architecture delivering the electricity itself. Even during service interruptions, attention tends to remain local. Extension cords, flashlights, portable generators, battery packs. The broader grid, the coordinated network of generation, transmission, and balancing, remains abstract. For most residents, electricity is treated as a utility service, similar to water or waste removal. It is billed monthly. It is expected to function. It is rarely examined beyond cost. The electrical grid is a centralized system designed for scale. Large power stations produce energy in bulk. High voltage lines transmit that energy efficiently across regions. Substations reduce voltage in stages to safe residential levels. Grid operators continuously monitor load fluctuations to prevent imbalance. This design allows millions of households to draw power simultaneously. However, centralization also introduces structural characteristics. Supply must match demand at every moment. Infrastructure upgrades require coordinated investment. Maintenance cycles occur across vast geographic areas. Failures in one segment can propagate if not contained. Households typically have no direct influence over these upstream processes. They cannot adjust generation capacity. They cannot repair transmission lines. They cannot reroute distribution pathways. The relationship is primarily one-directional. Electricity flows inward, payment flows outward. The infrastructure remains external to household control. Outside centralized grids, other energy formats exist. Small-scale solar arrays convert sunlight into electricity at the point of use. Wind turbines capture local wind movement. Fuel-based generators produce power mechanically. Battery systems store limited amounts of energy for later use. Mechanical storage technologies, including flywheel systems, have historically been used in industrial contexts to stabilize energy output by storing rotational motion and releasing it when required. Each format operates under physical constraints: intermittency, fuel supply, mechanical wear, storage capacity, conversion efficiency, or regulatory requirements. These alternatives do not eliminate infrastructure, they rearrange it at different scales. Instead of regional coordination, they introduce localized components: inverters, controllers, storage units, mechanical assemblies, or fuel logistics. The complexity shifts from distant facilities to nearer systems. The underlying challenge remains the same: electricity must be generated, regulated, and delivered in usable form. Within this broader discussion of centralized dependency and localized formats, some independent guides and digital programs document specific small-scale system configurations intended to reduce reliance on external supply. These materials generally present structural schematics, component lists, and assembly sequences for mechanical or hybrid energy setups using accessible parts. They are positioned not as replacements for public infrastructure, but as alternative configurations operating within physical and technical limits. Such formats exist within the wider landscape of household energy experimentation and decentralization efforts. Electricity in the modern home appears simple because its complexity is distributed elsewhere. Generation occurs remotely. Regulation occurs continuously. Maintenance occurs out of sight. Billing summarizes the result. The system functions through coordination across distance, equipment, and time. For most households, this infrastructure remains invisible until interrupted. Understanding that electricity is not a switch, but a layered network, does not prescribe action, it clarifies context. Behind every illuminated room is a structure extending far beyond it.